Our next speaker is Nick Buraglio. He's a network engineer, architect, and security engineer based out of Central Illinois. Currently works for ESNet, and he's going to be discussing secure layer 3 software-defined exchanges.
Hi. So as I was doing this, I sort of realized that it's more about interdomain SDN than it is an SDX in particular, but that didn't occur to me until like the train ride up here, like 3 hours ago. So basically, the idea came to a couple of us, Anita, Dale, and myself, about probably 18 months ago. We wanted to talk through and come up with a concept for building a secure software-defined exchange. Because some of the SDX work that was going on, we wanted to get involved and in contact with those folks and make sure that some of the security requirements and needs were being addressed with a lot of this research that was going on, because it's such a new and novel concept. So we wanted to provide sort of an out of the gate secure environment rather than having to bolt it on later. And so we did quite a bit of research in some of the things that are existing out there today, and found that we definitely needed to spend some time on it. So here's my disclaimer. This slide deck is nearly 100% buzzword compliant. So get out your bingo cards, and it's missing things like DevOps or cloud, but I said them right there. So now there you go. There's your freebies. It also there's a lot of hand waving involved here. It's not intended to be a throw out your IXP or your interdomain routing and do it this way. Nobody's baby is ugly. This is just a concept that we want to work through, because I think it's going to start happening, and we want to be ahead of it at that point. So the motivations were that this kind of says it all, right? I mean, there's lots of SDN. There are expensive products existing out there today that people are buying and putting in production that are doing OpenFlow and other types of proprietary SDN and non-proprietary SDN things. And securing the frameworks, we want to secure the frameworks before they're too far down the path that it becomes, quote unquote, too hard to do. A good example of that, I'll give it a little bit later, but there's some pretty good examples of that. And in this room, I'm sure we can probably think of some of these. It's not meant to be a replacement for peering fabrics or anything like that. Those reasons are just the tip of the iceberg, right? So how do we do things like exchange SDN policies between two autonomous systems or two autonomous networks? How do we handle authentication and authorization between controllers, if we choose to do that? How do we securely peer applications between ASs without exposing too much of the raw element underneath? And I think that, okay, a show of hands, how many people in here have actually thought about SDN? Right, pretty good amount, right? It's kind of hard to ignore at this point. How many people have thought about interdomain SDN? Exactly, people are thinking about it, right? So we need to figure out how to do it in a way that's intelligent. And the biggest reason really that we came up with to think about this is, why not, right? As someone that works in the scientific community, a negative result is still a result. So even if we go down this path and we find that it's not a good way to do things, or it isn't something we want to do, we still have that result, and we've done the research. So that being said, the goals are pretty straightforward. We think about what needs fixed now. We think about what works well and what doesn't. We think about what problems we can solve. We want to avoid change for the sake of changing things. And we want to be able to authenticate and validate resources exchange, provide the ability to exchange those SDN policies as opposed to exposing raw hardware, keep and enforce the policies within the AS. That's a key one right there. We also think it's important to remove the need for topology awareness between systems, and preclude the need for signaling between controllers if we can get away with it. It's important to think about the things that we need now that aren't required, such as filtering and the need for human interaction, simple changes too, because basic stuff like BCP 38, your outbound filtering of your routes is not implemented in a staggering number of networks, big networks. So that's the thing I was alluding to earlier, is think about these things that aren't done now that are perceived as being too difficult or too hard or too clunky to maintain, and build them in from the get-go and make them just part of the way you do it. I think will solve a huge amount of problems as people start to do these types of things. And to distill those goals a little bit more, we wanted to, the interdomain communication piece is difficult. Like in some cases we wanted it, in some cases we didn't. But we basically want to accomplish securing between the two interdomain, entities with validation and abstraction of the software-defined part of the deployment, right? We don't care what the software-defined part is in your campus or your enterprise. There needs to be a common Rosetta Stone in between them that can translate and push out policies and changes based on predefined criteria. So at the high level, you basically have this, right? You've got your devices at the bottom. The yellow devices are your network equipment, right? You got a VLAN switch or an MPLS switch, and you've got an OpenFlow switch. And those clouds are two autonomous systems, are two separate networks maintained and managed by two different people. They could be in the same enterprise but run by different departments. It doesn't really matter. Within the gray box, you've got, and this could exist on one host, right? You've got your controller, which is your SDN controller. It can be anything from an OpenFlow controller to homegrown stuff that some guy wrote 20 years ago. Doesn't matter, right? And then you have the policy arbitrator, the policy enforcement device in the middle, or the validator. And then at the top, BGP, or BGP FlowSpec, this is very appropriate because we went really in depth with that earlier. So that's a key element to this, is utilizing BGP FlowSpec for dissemination of that data. And in the practical function that we built, the proof of concept, we used BGP, which is an open source BGP tool. It's not a router per se, it's a BGP tool that allows you to do FlowSpec. And then the little fancy bubble there, I'm just calling magic code, right? That's the middleware. We'll talk a little bit more about that later. That's sort of the reason that I'm giving this talk, but I'll get into that a little bit more. But for right now, just think about it as these aren't the droids you're looking for, right? So in practice, when we built the proof of concept, here's how the packet flows, right? A request comes in here, and that request can come any number of ways. The mechanism for that request is sort of irrelevant, right? It's dependent on whatever that site tends to use. That comes into the controller. The controller, as we said before, can be whatever. I'll use an OpenFlow control as an example. Request comes in to make a change. That change goes up to the policy validator via a plugin on the OpenFlow controller. The policy validator says, yes, this change is allowed. It fits within our security parameters. You're allowed to be authoritative for these resources. Magic Code grabs that request, munges it into something that BGP understands, like a BGP announcement, sends it up to the the BGP speaker. The BGP speaker just announces it as a typical FlowSpec announcement. Then on the other side, the receiver grabs that as if it's just a BGP announcement, unpacks it, sends it down to the magic code. The magic code says, oh yes, you're allowed to plumb this flow mod through our network. Sends it, it sends it to the policy validator to do that. Then there it pushes it down to the controller. Controller makes the change, right? It's a fairly simple change process, right? You'll notice that there is no acknowledgement of that in here. That's still a limitation that I'll talk a tiny bit more about. But the proof of concept is sound here. For doing this in an internet exchange fabric, really all you're doing is adding another bubble. It doesn't really make a difference that it's an exchange in this case. It just can exist as another entity that connects, and it may also be a transit entity as well is really the only difference there. It allows, it doesn't make a difference. It will allow for both bilateral and common peering point, just like a traditional exchange, as long as it's got all the same pieces. And you can do the policy framework will obviously be a little bit different. So through the fabric, here's sort of the purple lines. I'm not sure why I didn't use the same arrows here. Apologies for that. But the purple lines are basically what a normal request would look like through an IXP. Basically you're just hopping over. Validation happens. It's all a series of bunny hops. The magic code, right? This is where the real meat is, and it's key to how it all works. Obviously, right? It's clear that this little hand wavy bubble here is what does all the magic, hence the name magic code. But the SDXs and the physical part are the easy pieces of this. The code to make the policy exchange is pretty simple, really, and it's really stable since it leverages BGP as its communication protocol. The policy framework code is going to be different in every location, right? That's dependent on security policy and politics and layer 8 stuff, at any given entity, right? So that needs to be written sort of based on whatever the rules are at any given site. But due to the nature of how it's all put together, it's modular. And that's by design, right? To make it, it's Legos, right? It's network Legos. So you can take things out, put things in based on how you want to connect and change your network equipment out or your security policy out. It doesn't make a difference, right? All of that can be changed and they all fit back together in a nice-ish type of way. So, removing the policies and features is less problematic than trudging through a bunch of monolithic code at that point. And in addition to that, the vision is that the code is modular in both directions, meaning that it can operate as a plugin for a controller or on its own. The middleware policy stuff, again, is sort of where the complicated bits come in, right? Because there's a certain amount of things that need to be taken into account based on what you're doing. You have to be smart about how you build your infrastructure and your policies around that, right? So you want to be able to check things as close to reality and networking as possible and that'll provide both protection for the infrastructure and a solid enforcement policy for your security and network elements, right? So you want to think about things like, if I'm using OpenFlow, how many flow mods do I want to allow for a given peer? How frequently do I want to allow them to update it? Do I want to do RPKI checks on layer 3 announcements and prefixes? Do I want to do actions based on BGP communities, which I think is always yes, but that's just my opinion. And then you want to be able to, this is the key part, is you want to be able to do translation between systems that have incongruent capabilities, right? If I can do OpenFlow, but you can't do OpenFlow, how do I change that out, right? So that's where the middleware policy framework comes in place. Is it has to be able to understand that these are the capabilities and adjust for them on the fly. In addition to those features, it's really important to keep this as close to traditional interdomain networking as it can be. Making it easy and requiring these things for the site to determine its own policy is a significant part, or else no one will do it. Allowing for the potential use of things like open flow matching and independent controllers is also key, right? So those elements are critical to making this work, right? Because if it's not easy, who's going to do it, right? I won't do it if it's not easy. So a few of the details, this is just a FlowSpec configuration here. This allows for the software-defined BGP announcements to contain the additional information. We went into this much better depth earlier today. But it's sort of the key to doing a lot of these things. And with the flexible nature of ExaBGP, You can do changes and you can, you can fork the code. You can do all kinds of things and make changes to it, do whatever you want to do. But that's what allows for the much more granular transitioning of traffic to different locations. Like if I want to send port 80 only to you guys, I can create that rule. That rule gets pushed across the fabric, for lack of a better description. That rule is accepted, and then a bidirectional rule is placed to say, my return traffic goes the other direction, and then the path is built. But traditional protocols go different directions. Only the ones that are configured go the way you configure them to. As you can probably imagine, there is a dump truck full of caveats involved with this, right? This is really a concept at this point. Policy conflict is probably the biggest out of those because it is difficult to handle those types of things going on within your network. How do you say, I can install that route or I can install this flow mod or whatever, but I don't have, I have a conflicting flow mod in there already. So you have to build, we haven't built any type of error accounting or anything like that yet. I suspect it's doable for someone that's a good programmer, of which I am not. So show us the code. Okay, so the proof of concept Perl code was created by that guy sitting back there in the very back. Raise your hand up, Dale. Right? He wrote it. It works. It does what it's supposed to do. And the proof of concept's there. It needs a little refinement, it needs some polish, and it needs more testing. And the main reason I wanted to come here and talk about this is because I want you guys to help. So if anybody's interested in looking at this and helping or whatever, or throwing rocks at it, that's fine too. Just get a hold of me. I did not put my email address on here. It might be at the beginning. But feel free to email me and we can work out some details and talk about it. That's it. Any questions? No?
Is there any working group draft at all? Is there?
Nope. You can start one.
Is there any working group draft for this sort of stuff at all at this time?
Not that I know of.
Yeah.
I mean, when we did this, it was how long ago was it, Dale? Like a year ago? Yeah, it was about a year ago when we really started doing the, putting boots on the ground.
Actually, the closest is the IDR FlowSpec.
Yeah.
Other IP actions.
Just for the microphone, the closest is the IDR working group in IETF, the other IP action stuff for FlowSpec.
Yeah.
I think part of the idea that at least Nick and Nita and I had was to forget the standards process and let's just write some code and see what works.
That's all we care about. I don't care about the standards process personally. I want code that works. I want things that do useful things for networking people that have too much to do already. Anyone else? No rock throwing or anything? Wow.
Is that code available, the proof of concept code available like on GitHub or?
We were just talking about that right before I came up here. It is currently not, but I believe we can make it that way.
Thank you.
Two-word question. Why Perl?
Why Perl?
It's quick and easy. I think the goal that we've decided on is that it should probably be Python. But like I said, I am calling me a poor developer is probably a compliment. So I can hack together simple things. I'm not one to be dictating that kind of stuff.
So this probably started with OpenStack, and you said that this can do translation to other SDN platforms.
It actually did not start with OpenStack. I have avoided OpenStack because from everyone that I've talked to that started working on it, it becomes a time hole that you have a hard time getting out of, and I don't have time. But the point is, yes, to do, and that's not a dig at OpenStack, I think it's really cool, I just don't have time. The point is to be able to do translation between software-defined networking islands. Right?
So the question is, what's working right now between what and what?
Between what and what? The code works right now between EXA-BGP speakers talking to Open Daylight controllers. And the version of Open Daylight is painfully out of date. It needs to be updated that we were using. But I don't see a reason why it wouldn't still. I mean, it's purposely meant to be simple, right? That's why we relied on EXA-BGP, right? Because it's BGP. Most people that are going to be doing interdomain stuff are going to know BGP, or they should. And so you can rely on that very rich history of network engineers working with this protocol that's a known quantity and known to be very stable. And this is just a new extension to it. So a lot of the fundamentals are still there, right? That was one of the main reasons that we went with that. And there's a couple other projects that are doing sort of similar things with BGP and flowmods, you know, Project Cardigan, and some of the Google research stuff is doing similar things with layer 3. But most of the other SDXs we looked at were layer 2, and so we wanted to focus on something that was larger than that.
Layer 2 easier to deal with?
Is layer 2 easier to deal with?
I'm not the right person to ask that question. I will avoid layer 2 like it has the plague. It doesn't scale, in my opinion, especially if you're trying to do large amounts of it over long geographic areas.
Anyone else? Yep.